Welcome all of you dear students. This is the most simplest and easiest way of teaching learning process in our most popular, most favorite YouTube channel Physics Make It Simple by Dr. Rajendra from Padmasri V.K. Patil Junior College, Pravara Nagar, Loni. As long as 12th Science Oscillations chapter is concerned, this is a lecture number 6, and in this lecture we have to discuss very interesting article, that is phase in SHM. So what is phase in SHM? That we want to discuss today. We know the equation of displacement of SHM is given by the formula x is equal to capital A sine of omega t plus phi. That omega t plus phi we call it as phase angle, and that phase angle is also called as phase in SHM, while that phi is called as initial phase angle. Remember well dear students, only phi is called as initial phase angle, while omega t plus phi, this total phase angle, we call it as phase in SHM. So what is actually phase in SHM? So phase in SHM is defined as a state of oscillation. What is the state of oscillation? That state of oscillation describes three factors. Number one, position or displacement of particle during oscillation. Number two, direction of velocity of the particle during oscillation. And number three, what is the oscillation number when the particle is oscillating. So these three factors are described by the physical quantity, we call it as phase in SHM. I will repeat again. This phase in SHM is nothing but a state of oscillation in which this state of oscillation suggests, this state of oscillation describes three factors. Number one, position or displacement of particle during oscillation. What is the position of the particle? Where is the particle? Whether the particle is in between mean position to positive extreme or mean position to negative extreme, or exactly at mean position or exactly at positive extreme, or either exactly or on negative extreme. Where is the particle? It suggests the position. It suggests the position or displacement of the particle. Number two, direction of velocity. What is the direction of velocity? Whether the particle is moving from positive extreme towards mean, or from negative extreme towards mean, or from mean to positive extreme, or from mean to negative extreme. That direction is exactly suggested by phase in SHM. Also, phase in SHM suggests oscillation number. What is the oscillation number? Whether that condition is in first oscillation, whether the particle is in second oscillation, or either in third oscillation or fourth oscillation. What is the oscillation number actually? That three factors are suggested by the physical quantity, we call it as phase in SHM. That's all. We will illustrate this by taking some phase angle. But remember dear student, you should clearly understand the definition at first. So phase in SHM is a state of oscillation which describes, number one, position into bracket displacement of the particle during oscillation. Number two, direction of velocity of oscillation, and number 3, oscillation number at that instant of time is called as phase of SHM. Okay, I have drawn a graphical representation of oscillation on the board. So let us observe the graphical representation. See here, this is 0, this is pi by 2, pi, 3 pi by 2, 2 pi, 5 pi by 2, 3 pi, like this. How we can remember this phase angle? So for that purpose, I will give you one idea that theta is equal to omega t plus phi. This omega t plus phi is called as phase in SHM, which is equal to suppose n pi by 2. So remember this formula in your mind. Theta is equal to n pi by 2. Theta is equal to n pi by 2, where n starts from 0, 1, 2, 3, 4, like this. So put 0 here. 0 pi by 2, we get 0. 1 pi by 2, we'll get pi by 2. 2 pi by 2, we get pi. 3 pi by 2 as it is. 4 pi by 2, we get 2 pi. 5 pi by 2 as it is. 6 pi by 2, we get 3 pi. 7 pi by 2. 8 pi by 2, we get 4 pi. 9 pi by 2. 10 pi by 2, we get 5 pi. 11 pi by 2. 12 pi by 2, we get 6 pi. Like this. So by making use of this formula, we can gradually write phase angle without any mistake. So here 0 pi by 2, pi, 3 pi by 2, 2 pi, 5 pi by 2, 3 pi, and so on. And for every 2 pi interval, by covering a 2 pi radian, that oscillation complete one oscillation. So here is a one oscillation here. After again 2 pi, that means when the particle completes phase 4 pi, second oscillation. Up to this third oscillation, up to 6 pi. Up to this 8 pi, this is fourth oscillation. So 1, 2, 3, 4, that is the oscillation number that I have quoted over the head of the graph. Then let us see an interesting thing. Let us see a fun. We will play a funny game now by taking some examples on the board. See here. At theta is equal to, take anywhere, theta is equal to 3 pi. What is the phase? What is the state of oscillation? At theta is equal to 3 pi. See here, at theta is equal to 3 pi. This is particle is at mean position. This is mean position. This is negative extreme. This is positive extreme. Positive extreme, positive extreme, positive extreme, positive extreme. All this is mean position of the particle. Negative extreme, negative extreme, negative extreme, negative extreme. Okay. Then see here. At theta is equal to 3 pi, what happens at theta is equal to 3 pi? Particle is at mean position. Particle is at mean position. Particle is at mean position. That is the position of the particle. What is the direction of the velocity? Moving from mean to negative extreme. Moving towards negative extreme. Moving towards negative extreme. During the which oscillation? During the second oscillation. During the second oscillation. That means this phase suggests position of the particle. This phase in SHM suggests direction of velocity of the particle during oscillation. This phase suggests oscillation number. These three physical quantities is described by the phase angle. We call it as phase in SHM. We will take another example. So the similar state of oscillation which we get after 2 pi interval. So here is 3 pi. Where is 3 pi? This 3 pi. After 2 pi, that means in 5 pi, at the time of 5 pi, it is in the third oscillation number at mean position moving towards negative extreme. Particle is at mean position moving towards negative extreme during the third oscillation. So here, after again adding 2 pi, 5 pi plus 2 pi, we get 7 pi here. The similar state of oscillation we get, only the oscillation number is 4. Particle is at mean position moving towards negative extreme and during the fourth oscillation. In this way, by making use of any phase, we can get 3 factors, that is I have already explained on the board. By taking a phase, theta is equal to 3 pi. Okay, we will take another phase. Take another phase. Suppose another phase is what? Take any phase. Theta is equal to what? Suppose theta is equal to 15 pi by 2. At 15 pi by 2, what happens? Theta is equal to 15 pi by 2. Particle is at here. Particle is at negative extreme. That is the position of the particle. Particle is at negative extreme. Negative extreme. This is the position of the particle. And it moves from negative extreme to mean position. It moves from negative extreme to mean position, moving from negative extreme to the mean position. This is the direction of velocity, and which is in fourth oscillation, during the fourth oscillation. During the fourth oscillation. So this is happen. The similar state we get by making difference of 2 pi here, similar state, which is at negative extreme moving towards mean position in the third oscillation. Again, at phase angle 7 pi by 2, it is at negative extreme moving towards mean position during second oscillation. Come here, when the particle is at phase 3 pi by 2, which is at negative extreme moving towards mean position in the first oscillation. In this way, by taking any phase, we can prepare a lot of questions. We can prepare a lot of questions. So we will try to prepare MCQs on the board. Let us take a screenshot at first. Take a screenshot. Okay. So I will clean the board at first, and we will prepare some MCQs as long as your various types of examination is concerned. We will see what happens. Suppose I will prepare a first question like this. State the oscillation number when phase of oscillation is 7 pi. State oscillation number when phase of oscillation is 7 pi. I have right here 1 A option, B 2 C option, 3 and 4 D option, here is 4. Which is the correct answer? Observe the graph. Observe the graph. The question is what? State the oscillation number when the phase of oscillation is 7 pi. Where is 7 pi? Here is 7 pi. So what is the oscillation number? This happens in oscillation number 4. So this is the answer. So this is the correct answer. That is the oscillation number. Then again, the next question we will prepare for the same. We will write here. State the position of the particle state the position of the particle during the phase 7 pi. Same question I will prepare. State the position of the particle during the phase 7 pi, and the option is like this. Number 1, particle is at number A, particle is at mean moving towards negative extreme. B option, particle is at mean moving towards positive extreme. C option, particle is at extreme moving towards, particle is at positive extreme moving towards mean position. Number D, particle is at negative extreme moving towards mean position. So what is the correct alternative that you can choose? See here, read the question carefully at first. The question is, state the position of the particle during the phase 7 pi. Where is the phase 7 pi? Here is the phase 7 pi. The particle is at mean position. This is at mean position. This is the mean position moving towards negative extreme. Mean position, mean moving towards negative extreme. This is the correct answer. So in this way we can suggest the position of the particle. Then what is the direction of the velocity? During the phase 7 pi? The direction of the velocity is from mean position to negative extreme. Same, mean position to negative extreme. So in this way we can prepare a lot of question. By referring this graphical representation, and by making use of this graph you can prepare a question consulting phase in SHM. So phase in SHM is a state of oscillation which describes position or displacement of the particle during oscillation, direction of velocity of the particle during oscillation, and oscillation number, in which oscillation the particle is, whether it is in first oscillation, second oscillation or third oscillation at that instant of time, that we will see. So this is all about phase of SHM. How this phase is to be remembered? So listen carefully, remember carefully this formula, theta is equal to omega t plus phi. That omega t plus phi is a phase of SHM, which is equal to n pi by 2, where n is equal to 0, 1, 2, 3, 4 and so on. 0 pi by 2, 1 pi by 2, 2 pi by 2, 3 pi by 2, 4 pi by 2, 5 pi by 2, 6 pi by 2, 7 pi by 2, 8 pi by 2 means 4 pi, 9 pi by 2, 10 pi by 2, like this. And by making use of that graph you can prepare a lot of questions regarding this. And such a difficult article we will make it more simple, and so that name of our channel is Physics Make It Simple. Dear students, remain continue, be alert, be studious. We will meet again in the next lecture. Till we stop here.